morning and welcome to People Online. This time we intend to do a series on HR analytics. The scope, however, is restricted to the very basics with an emphasis on applications, particularly those kind of applications that require less resources to run and perhaps can be best described as low-hanging fruits.
Session 9. Prescriptive Analytics. Analyzing problems using root cause analysis. Contents. In this video, we would be covering what is prescriptive analytics, what is a problem, problem-solving tools, and a 5-step problem-solving methodology. What is prescriptive analytics? Prescriptive analytics advocates analyzing HR data to acquire greater insight about a problem and then recommending a course of action to resolve or manage that problem. For example, analysis of attrition data to come up with anti-attrition measures. There are two broad approaches of prescriptive analytics that are in practice. A. An approach using root cause analysis borrowing heavily from practices in quality management. And B. An approach using tests of independence as guided by statistics. This video presents option A. What is a problem? We have a problem when there's a gap between what should be happening and the actual situation. The causes are unknown and we need to know that to take effective action. Problem-solving tools. Here we will be discussing two problem-solving tools. These are Fishbone Diagram and Pareto Analysis. Fishbone Diagram. This is a means for recording and presenting all possible causes for an effect or an event, which is typically a problem. The causes are identified through brainstorming and then organized under logical clusters. Conventionally, as you can see, 4 clusters are used, namely material, method, machine, and man. Fishbone diagram was first used by Ishikawa, a Japanese engineer. It is therefore also called Ishikawa diagram, also goes by the name 4M diagram. Fishbone diagram is a handy tool for problem solving as it helps to capture all possible causes of a problem so that objective investigation can be initiated. We see here how fishbone diagram is to be used. The problem that has been taken up is a table lamp doesn't work, in the sense that we power it on but it doesn't light up. A table lamp can be thought to be made up of 4 components. 1 is the bulb, 2 could be the power supply, 3 could be the plug and cable, and the 4th element could be the rest of the table lamp, the body of the table lamp. Each cluster or each bone can further be broken down to sub-causes, and for example, power supply, we are seeing there's no power because the circuit is fused or there's a power cut. Similarly, the issue with the bulb could be that it's broken out, it's burnt or broken. And for the plug and cable, it could be that the cable has been cut or the plug has not been put in. And the issues with the lamp could be there's a contact problem or the switch is broken. Pareto Analysis. This statistical tool is named after the Italian economist Vilfredo Pareto, who noted that 80% of the land in Italy was owned by 20% of the population. Pareto analysis tries to identify the most frequently occurring contributors to a given outcome. In the context of problem solving, if the most frequently occurring causes can be eliminated, the problem can be controlled. A Pareto diagram consists of histograms representing the frequency of occurrence of the causes plotted in decreasing order. Pareto analysis, an example. We are referring to the earlier problem of lamp not working. We had seen a fishbone diagram, and here what we are presenting in the table on the right hand top corner is basically data available on failure. So there were 38 complaints which were received by the people who were responsible for carrying out maintenance work. 38 times they received a complaint that the table lamp was not working. And the failures were analyzed and basically they came up with the following data. Socket fused happened 10 times. Bulb not fitted correctly 3 times. Power cut 5 times. Bulb burnt out 16 times. Not plugged in 4 times. So it could be seen that cause 1 and cause 2. Cause 1 is bulb burnt out, which is the highest, which has got the highest frequency of occurrence at 16, and cause 2, which is socket fused with a frequency of 10. So between them, 16 and 10 is 26. 26 by 38 is 68% of the occurrences can be attributed to just these two causes. And we have here 5 causes which were at play. So 2 by 5 is 40% of the causes, almost accounting for 70% of the failures. A problem-solving methodology. This problem-solving methodology is widely practiced in quality management. There are 5 steps which have been listed below and elaborated in the subsequent slides. The step 1 would be defining the situation. Step 2, fix. Step 3, root cause analysis. Step 4, corrective action planning. And step 5, evaluation and follow-up. Step 1, define the situation. The problem has to be defined in quantifiable terms. That actually makes up the problem statement. The desired state, which when achieved, once again in quantifiable terms, would signify that the problem has been eradicated, and we call it the desired state. Step 2, fix. These are temporary measures which can prevent the situation from worsening any further. These are often expensive, ungainly, and work over short periods, certainly not sustainable over a long period of time. These measures are brought into play without much analysis and are often reactive in nature. They are useful in buying the much needed time that is required to analyze and work out a proper solution. Step 3, root cause analysis. There are 2 parts here. A, listing out all possible causes of the problem. This is arrived at by brainstorming, and subsequently the possible causes are segregated into logical groups and presented typically through a fishbone diagram. B, determining the key causes, termed as root causes. A survey is launched using primary or secondary data to determine which out of the causes listed under A has occurred most frequently. The tool that is popularly used to carry this out is Pareto Analysis. Step 4, corrective action planning. Once the root causes have been identified, corrective actions are initiated to neutralize them. A list of possible actions are drawn up through brainstorming involving all stakeholders. These are evaluated subsequently using a few parameters like cost, ease of implementation, etc. Weights may also be ascribed to these parameters. Ratings may be obtained from a panel of experts. For each root cause, the highest scoring corrective action is selected for implementation. The corrective actions are then rolled out like mini projects, each comprising of a number of connected tasks, start and end dates, ascribed accountabilities, and budgets. Step 5. Evaluate and follow through. One needs to now check whether corrective actions have been completely implemented. Subsequently, the results need to be checked. Has the problem been eradicated? If yes, the project needs to be closed. If the answer is no, we need to redefine the problem and restart from step 1. Summary. In this video, we have discussed 1. What is prescriptive analytics? 2. What is a problem? 3. Problem-solving tools. And 4. A 5-step problem-solving methodology. Thank you for watching. If you could relate to the video, if you found it to be useful, do like and share. Do subscribe to our channel. Press the bell button to stay tuned in for our next video. Until then, goodbye.